Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about two different processes you can use to evaluate a mooring system. One is a time domain analysis of the mooring in a sea state, and the other is a maximum design wave approach. So what's the difference between the two of these? Well, one of them is on the left here. We have an ATON buoy system in a fairly shallow water wave condition with for pretty extreme sea state conditions of 10-meter significant wave height with the current. And what we're doing is we're seeing how it responds to an irregular sea state. So we run a long simulation time, we see what happens, characterize the loads, and run multiple realizations of that sea state and get a good statistical understanding of the peak loads. The other way of doing this with the maximum design wave approach is rather than going through that, we try to establish some representative maximum individual wave you may expect to see in this particular sea state condition. Then we apply that wave height as a sinusoidal airy wave ramping up from zero in one period, and then in the next period the maximum wave itself. So if we run through this, this is a 10-meter significant wave height on the left. We may see something like a factor of 1.9 or even 2 on that maximum wave height you'd expect to see in these extreme scenarios. And in fact, it's so extreme it's submerging the buoy. So what's the advantages and disadvantages of each of these approaches? Neither of them is right or wrong. There's, on one hand, what's really nice about the maximum design wave approach is, well, you only need to look at a relatively short simulation in which you have this ramping up airy wave condition. And on the other hand, you have to run potentially a long set of simulations, more than one realization, to really characterize those loads. But there's also downsides to the maximum design wave approach. I mean, there can be uncertainty on what that maximum wave really should be, and it may end up producing pretty conservative results. In fact, the maximum tension we see in this scenario is something on the order of 100 kilonewtons, whereas we're seeing something more like 60, 70, 80 kilonewtons. Although this is only one realization, it's not necessarily the maximums. Note one thing you can do also is if you check out the simulation results, when you're running a sea state spectrum, this wave stats probes information gives you an expected worst case peak trough as measured from the as simulated condition. And you can see that we see something like a 16 meter trough to crest wave that's passing through here. So it's good to know, that's a way of kind of verifying, well, we actually really are seeing some pretty extreme conditions that are not that far off from that 19-meter wave. But also, it's a very coherent wave that's slamming into the system. And in reality, there's a bit of spreading that kind of, mitigates how much that would actually happen. So on one hand, you have maybe a little bit more realistic effects in representing the sea state spectrum. It does mean you need to do a lot more analysis. And on the other hand, you have a simpler approach, but maybe you might be coming up with more conservative loads. Of course, you need to use your judgment and build up a comfort level in going through all this, but it's a way of doing things that it's a different philosophy of doing things in the mooring analysis process, and well worth knowing about. Thanks for watching.